G'day guys, another round of cheap crap from China. A few more packages today, so let's go through them. First up, we have an ECG module. So this is actually the second one of these I've received. Wow, those pads look in horrible shape. The first one mostly seemed to work, but the first time I plugged it into a breadboard, I got sort of a half-dim light out of it, and noticed that the power supply that it was plugged into, the lights were dimming on that, so something was drawing a heck of a lot of current. I still don't know what the problem was. I had basically just the 6 pins of the module plugged into the breadboard, and only power and ground plugged in otherwise onto those same rails. And yet, yeah, I unplugged the module from the breadboard, attached 2 wires directly to the power and ground pins, and ran those to the breadboard, and that was fine. It then powered up properly, no excessive current draw, no problems. So I don't know if that breadboard has like an internal short, or whether it was just a capacitive loading on the outputs that was making something go haywire in this chip, or what. But playing around with the module after that, I couldn't get a proper output out of it. Like, it wasn't giving me any noticeable signal. So I figured, screw it, they're cheap enough. I'll get a second one, and that way I can confirm what the actual problem was. If I can get both modules going, then that would be great. Because as much as these are designed for electrocardiograms, looking at your heart, my interest in them is for EMG. I'm not even going to try and say that out because I'll get it wrong. But the idea is that an ECG works because it's detecting the electrical activity in your heart, in the muscles of your heart, because the heart is essentially one giant muscle. The same practice works elsewhere on your body. For instance, there's a good example where having one pad on the bottom of your hand, one pad on the top, and one pad back on your arm, the grounding pad back on your arm, each finger, when moved, will give a different response to that sensor. And so theoretically, with the right amount of processing, you could actually tell where each finger is purely from the contact on the top and bottom of your hand. And so the next extension of that is to maybe build it into a glove, even like fingerless gloves, something like that, that can just go around the base of your hand and will then pick up where your fingers are moving. So I'm not necessarily saying this is going to be any less janky than, say, the Leap Motion. I mean, there are a lot of variables, and any small change in the signal could be misconstrued as, oh, your pinky's flying up and down, or something like that. But it seemed like a fun little project to dive into, possibly something to throw a neural network at, to learn the different movements for each finger and then what they look like when they're combined. And in general, just to play around with. So that was a little project to go on with. Otherwise, I did also get a few new packages the other day, which I have already opened. I only received sort of 2 packages in one day and then 1 package the next day. So I figured it wouldn't be enough to make a mailbag out of. Then I opened them and saw what they were and regretted not putting them aside. So the first one is this. This is the TT Go microcontroller Arduino Nano-ish module. So now this is the module that I was talking about last episode, or the one before, where it is an Arduino-like module, but it is not an Arduino. It will not directly accept Arduino code. You need to change some compile time options. But it is better than an Arduino in basically every way. It's made by Wemos, who you may know from ESP8266 and ESP32 boards. They make a lot of quality products, and it's a fairly simple board. You've got USB to serial, voltage regulator, and the microcontroller itself. Let's see if I can actually focus in on this chip. Do we have any markings? No, I can read the other ones. But the microcontroller itself is completely blank. Okay. But yes, I did sort of check into it in the meantime. It is a TTGO XI 8F328P-U, replacement for Arduino Nano or Pro Mini. The microcontroller is an Alpha 8F328P. It's an Arduino compatible board. You can use the Arduino IDE. You need your own installation support. The USB chip is Thailand Holtec 42B534-1. The architecture is relatively new. Peripheral function is far stronger than the ATmega 328. Especially the program encryption capability is far beyond the 328. And so if I look at the features here, it has 8 hardware PWM channels, a maximum clock of 32 MHz. It has an 8 kilobyte EEPROM, a 6 channel and then 12 channel multiplexed ADC. It has a hardware DAC with 8 channel multiplexer, hardware UART, hardware SPI, hardware I2C, a hardware GUID generator, a plus and minus 0.5% internal voltage reference of 1.024 slash 2.048 slash 4.096 volts, and fairly sort of typical 2K of RAM and 32K of flash. So it's still not as powerful as, say, an STM32 microcontroller, which I've become quite a fan of lately. But it does have quite a few useful features. And these are quite cheap. It was $2.20 Australian, including shipping, to get this thing. So I figured it was certainly at least worth a play with one of them and see how they go. And I'll try and make a dedicated video on this, both testing it out with the Arduino IDE and comparing it to a regular Arduino. Possibly even the STM32, although I don't think that's a fair comparison. I may sort of try and cover the spread of the different items that are available. Especially these days, there are so many microcontrollers out there, and honestly most of the battle is just knowing what's out there, what's available, what you can get. It's not so much a problem to change your architecture these days, because there's compatibility layers and hardware abstraction layers and all this sort of stuff. Until you get right down deep and you're programming raw assembler on the chip, you can pretty much port any C code you want to a different platform. It's not that hard. And especially these days with very powerful microcontrollers being so cheap, if you are down at that level writing raw assembler to run on the CPU, then you're kind of doing it wrong, right? If you need that tighter performance, then you should probably be just looking at a more powerful microcontroller. But hey, the next part was these. Which is a much nicer set of digital calipers. So these ones here have been my old trusty set for quite a while, which they work. They have 0.1mm resolution, which honestly is usually fine for pretty much everything I do, because most of the measurements that I take are to make parts for 3D printing. So the 3D printer doesn't have resolution much better than 0.1mm anyway, so having measurements down to 0.1 was quite adequate. The problems I had with this were the plastic jaws, or the entirely plastic construction, which can be good in some cases in that I can be confident this isn't going to scratch anything, but I'm really waiting for some substantial damage to happen to some of these, to the jaws, and the calibration to be thrown way out. You also can't calibrate this unit. You can zero it, but sort of if you get it so it's consistently, every time you move it out to 150 mil, it reads 148 mil, there's nothing you can do about that. Plus, also I've just been literally throwing these in the toolbox, so they've been getting beat around a bit, and again, plastic construction, not great. Finally, a couple of missing features. Those of you who have used some proper calipers will probably notice that there's no set screw here to lock the head in place. So if you're sort of judging the gauge of a hole, it's very helpful to be able to lock that in place and then move the thing around and make sure that in all dimensions the hole is the same. This just can't do that. And there's no fine adjustment wheel here. So the only way to move this thing is to actually sort of drag it forward and backwards, which is kind of nasty. Especially for fine movements. For big movements, it's okay. But so this is the new set. These are accurate down to 1/2 of a thousandth of an inch, or 1/2 of a mil. Or in millimeters, you have accuracy down to 0.01 millimeters. So it obviously has the fine adjustment wheel I was talking about, where you can very precisely change the position. It has, obviously that's very, very fine, 0.01 of a millimeter there, where it will get to 0.0, where it's clamped completely tight, but if you move the arms, then there now is actually a little bit of free play between those. It's not a perfect mated surface. So yeah, that would be 0.01 millimeters away. And obviously you can still drag it back and forth. The action on this thing, the sort of, when you're moving it back and forth, it's quite gritty. It's not exactly the nicest, but I do think they will hold up much, much better than the plastic ones, even though the plastic ones have held up pretty well for me so far. We do have the set screw to be able to lock it in place, so now that you can't accidentally change it. So if you want to make sure that multiple holes are the same diameter or whatever such, you can do that. And finally, there is actually a button combination you can do to recalibrate it. So that if the calibration gets wonky for any reason, or there's ever any problems with it, you can recalibrate and sort of maintain it as a tool. Thankfully enough, it takes the same battery as the old one, so I was just able to swap that over. But yeah, so my old calipers, these ones, I think I spent $6 or $7 on, including shipping. This set was $17. So, I mean, it's a bit more than twice the price, but still not a hugely expensive item, especially for a tool that, well, I tend to use so much. I'd far rather go for the calipers than a tape measure or anything else like that, at least for measurements within its range. And we have, these USB alligator leads. These have been super handy. So they come with a set of a female USB and a male, 2 alligator clips. And they are nice, heavy gauge wires. I'm not sure how thick the wire is in that section, but being like 2 inches long, it's not really a big problem. But yeah, they handle easily 3 amps and are just brilliant for testing, whether it's powering something from a USB power bank or hooking up a dedicated 5-volt supply to a USB device. They're just super handy. So I already had one set, but I bought another 2 just to stock up. Oh god, QC pass. Yep. Because I trust that. Okay. Another simple one. USB 3 extension cable. So this doesn't feel as heavy gauge as the one I got yesterday, but still doesn't feel bad. Now, here's the one I got yesterday for comparison. This one has a sort of softer silicon rubber. If anything, this wire may be a bit thinner, yeah. But this one certainly feels higher quality. But I'll try them out, see how they go. There's not too many things they can screw up with a extension cable, I hope, as long as they're decent gauge wires. And with USB 3, I guess that there's not too much interference. USB 3 to Type-C, or Type-C to USB 3. I don't have any devices that take USB Type-C, but my computer has about 3 Type-C ports. So I figured something like this would be handy to give me a couple more proper USB ports. Okay. It's going to be a painful one to open. Aha. Been waiting for this thing for quite a while now. So this is a DisplayPort to HDMI adapter. And had to do quite a bit of shopping around because most of them will do 4K, but 4K at 30. And that's kind of my problem at the moment, is my work monitor, like my work laptop, has only DisplayPort out as well as a legacy DVI port. And so the best I can get out of the DVI port is 4K at 30. So with my nice shiny new 4K display, I'm not normally that much of a, not normally that fussy about frame rate. I don't really care if it's 30 or 60 for movies, but for a work computer it was actually really noticeable that the mouse was sort of jaggy and just slow and sluggish. And so this does say 4K 60 Hz active. So yeah, I'll give that a go soon and see how it goes. I think that was $18. But that was the cheapest I could find that did actually do 60 Hz. Oh, very exciting. A fan. I've ordered a bunch of fans recently because the power supply on my desk has a fan with a dodgy bearing or whatever, and it's just randomly decided to start making noise, usually at about sort of 5 AM, an hour or two before I get up. So, kind of annoying. And I realised that while I used to have a huge collection of PC fans for fitting in just about anything, all different sizes, I don't really have that many anymore. So I ordered a bunch of 60, 80, 120mm fans in 2-pin, 3-pin and 4-pin varieties. So this is the first one to arrive from that set. Not a bad little 60mm fan. Okay, nothing too exciting. Hope you enjoyed, and I'll see you next time.